Okie doke, so I want to go over the study guide for Unit 1 test. This test will be administered this Monday. Alright, so problem 1 is asking us to find the volume of this prism here. And of course we need to explain or show our reasoning. So what I've done is I have highlighted the part of the prism that I'm going to be calling the length, because I'm going to be using this formula here, length multiplied by width multiplied by height, to find the volume. So the length is 7 inches. Next I need to determine the width, which I've highlighted in blue. The width is 4 inches. And then lastly, the height is labeled as 5 inches. So the volume formula instructs us to multiply these values together. And that's going to give us 140 cubic inches for the volume. So everything I showed here is showing my reasoning. Okay, so if this were a test question, students would score 2 points for the correct volume, and they would score an additional 2 points for a total of 4 points for showing their work. Now, the other formula here that is usually not used quite as often is the area of the base multiplied by the height. Now the base is this face here of the prism that is the prism is resting on. So you can kind of think of this is the surface of the base that's making contact with whatever it's sitting on. So the area of this base is simply the length 7 multiplied by the width 4, and that would give us an area of 28 square inches. And then multiplied by the 5 would give us the same volume, 140 cubic inches. Okay, so the next question is a little bit different. So again, we're shown a rectangular prism, but the problem asks us to explain or show how this expression, 4 times 48, represents the volume of the rectangular prism in cubic units. Well, referring back to this area of the base multiplied by height formula, we can see that the area of the base, which is just the length times the width, is 48 square units. So this 48 that we see represents the area of the base. And then we can multiply that area of the base by 4 units. So if I were to write out an explanation, I could say the expression 4 multiplied by 48 represents the volume of this prism because I know the area of the base multiplied by the height results in the volume of the prism. So, students wouldn't necessarily have to go about reasoning out this problem exactly the way I did, but this is an example of how a student could interpret 4 times 48. Another way is students know that the length and the width are 48 and that they have to multiply the length, the width, and the height to find the volume. So they might interpret the 48 as representing that length times width and then multiplying by that last dimension of height, 4. The third question here is a word problem that asks students to select expressions that could be used to find the volume of the rectangular prism that's presented in this problem. So the problem states a box is shaped like a rectangular prism. Its measurements are 6 centimeters by 2 centimeters by 15 centimeters. We are asked to select all, and these words are bolded to emphasize that there could be more than one answer, expressions that represent the volume of the box in cubic centimeters. Well, if we think of the length as 6, the width as 2, and the height as 15, we immediately notice that expression A could be used to find the volume of this hypothetical prism. We may also notice that 6 times 15 gives us 90, leaving the 2 to be multiplied with the 90. So the expression 90 multiplied by 2 is also an accurate expression for this volume. If we look at E, we can see that what this expression took advantage of was knowing that 6 and 2 give us 12, with a 15 remaining to be multiplied. So 15 by 12 would also be an expression that works to find the volume of this hypothetical prism. Now looking at C and D, C has an expression 12 times 30. Now I can see where the 12 could come from this 2 and 6, and I could see a student thinking, well, maybe 6 and 2 is 12, and 2 and 15 is 30. But we know that once we've multiplied 6 and 2, we're only left with 12. So the 2 that was a factor with 6 gets absorbed into the product 12. So C is not a reasonable expression. Likewise, looking at 8 multiplied by 15, we can see where the 15 does relate to a dimension in the problem, but this 8 appears to have been the result of adding these two dimensions, the 6 and 2. And we know that with the 3 dimensions of a rectangular prism, we're not adding these dimensions, we're multiplying them. So D is also incorrect, leaving us with just A, B, and E as correct expressions. This problem is labeled 4, but it actually contains 2 different figures. So the first figure appears to be made of unit cubes, and the way that I'm seeing this is that there is a larger prism behind a smaller prism. Now again, this isn't the only way students could interpret this problem and still get the correct answer. But this is just an example of how I'm visualizing the problem. So I see that this is actually a compound figure that's made up of 2 prisms. Now the prism that's in the back here, shaded in orange, we can see that there is a top layer of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cubes. And then we can see that there's 2 layers. So 2 layers of 12 is going to give us 24. So the volume of this orange rectangular prism is 24 cubic units. And we can simply see and count that the smaller green prism has 4 cubic units. And when we add these two separate volumes together, we get a total volume of 28 cubic units. Shifting our attention to the compound figure below, this figure is not composed of unit cubes. So observing the two prisms that are contained within this figure is a bit harder to see. As always, there is more than one way to separate this figure into two prisms, but I've chosen to separate this figure into a prism here on the left and a prism here on the right. And again, I'm going to use colored pencils to shade in both prisms. And then I'm going to label each prism. Now again, your choice to label is totally optional, and you can label using letters, pictures. You could even name each prism a silly name like Fred and Bob. It doesn't matter. I just like to distinguish the two prisms from each other in order to organize my work. So I'm going to find the volume of A, and I'm going to find the volume of B. And then once I've written expressions for the volume of both prisms, I'm going to add them together to find the total volume. So I'm going to use length, width, and height for each prism. And looking at prism A, I'm going to identify the length as these kind of pinkish purplish lines. And I see the length is 6. Next, I'm going to identify the width of A. And while the width is not labeled anywhere on the prism A, it is labeled down here with prism B. And we need to recognize that the entire figure has a width of 4. Lastly, with prism A, we need to identify its height. And I'm making that dimension a bit more clear by including these blue lines. We don't know what the height is here, do we? It does not tell us. So instead, we need to use what we do know to figure out what we don't. So we know that the height of B is 6, and that means that this distance here is 6. And we know that this small height here that's starting at the top of B going to the top of A is 2. So that means that this section there and this section here have to add up to this total, the total height here. So 6 and 2 added together gives us 8. So the height of A would be 8. Okay, now turning our attention to B, I need to identify B's length. And B's length is labeled. So we know the length is 8. We know from figuring out the width of A that the width of B is 4. And the height of B is labeled as 6. So now all that's left for me to do is evaluate these two expressions and then add them together. So I know 4 and 3 is equal to 12, and 12 times 6 is 72. So the volume for A is going to be 72 cubic inches. Looking at the expression for B, I know 8 multiplied by 4 is 32, and 32 groups of 6 would be, let's see, 6 times 30 would be 180, and 6 times 4 would be 24, so 180 and 24 is going to give me 204. So the volume of B would be 204 cubic inches. So lastly, I'm going to add these two volumes, 204 cubic inches to 72 cubic inches, which is going to give me a volume of 276. Now it looks like I feel like I might have made a mistake here, so I'm going to double check my work. I'm going to go over and see if I have the correct length, width, and height. So for A, the length is 6. Okay, that checks out. The width is 4. That checks out. And the height is 8. Okay, so that checks out. All right, let me check my dimensions for B. So 8 is the length. Okay, we know the width is 4. And then the height would be 6. Okay, so I have my dimensions labeled correctly, but maybe I might have made a multiplication mistake. So let's see here. I multiplied these numbers in my head. Maybe multiplying them out on paper is going to help me out here. Okay, so I think what happened was when I multiplied 6 and 4, I multiplied 24 by 3. Because I didn't write my 8 very clearly. So that messed up the rest of my work here. So let's get rid of this 72. So 6 and 4 is 24. Let me multiply 24 by 8. I get 192. So my suspicion was correct. I did make a mistake. Now let's check over here just to be sure that I didn't make a mistake over here as well. So 8 times 4 is 32. And then I'm going to work out 32 by 6 just to be on the safe side. So 6 times 2 gives me 12, carry the 1. And then 6 times 3 is 18 plus the 1 is 19. So I made 2 mistakes here. So if I hadn't had gone back and checked my work, I would have had the right process down, but I would have ended up with the incorrect volume. So it's always very, very important to check your work every time that you solve a problem, because you never know if you made a silly mistake. I wrote this 8 as a 3, and that gave me 72 when I simplified this expression, when the actual expression for volume A should have been 192 cubic inches. Looking over here, while I did multiply 8 and 4 correctly, I made a mistake when I multiplied 32 by 6. So I slowed down and I wanted to make sure I wrote it on paper just to be on the safe side. And it turned out that my mental calculations were incorrect. So now that I have the 2 correct volumes for A and B, I can add them together. And now I'm confident that I have the correct volume. So the total volume for this composite figure is 318 cubic inches. Okay, so moral of the story is double check your work. Okay, so it looks like we have another problem where we're selecting expressions that match what the volume of this shape is. Okay, so I like to start with the volume formula to kind of ground myself in this type of problem. So I'm going to identify the length as 1, 2, 3, 4 unit cubes. The width is 1, 2, 3, 4 unit cubes. And the height is 1, 2, 3 unit cubes. Okay, so I have an expression of 4 multiplied by 4 multiplied by 3. Let's see if I have any expressions that match that. Now, looking at expression A, there's a 4 and a 4 and a 3 in the same order I have here, but there's addition signs in between these numbers where there should be multiplication signs. So I know that A is definitely not correct. Okay, so 16 times 3, I'm not really sure if that's correct or not. Right now I'm really just seeing if I can find my expression 4 times 4 times 3. So, I do. Answer choice D. Okay, so I know that answer choice D or expression D works. But because I need to select all expressions, I want to go through and just double check each of these expressions and see whether they work or not. Alright, so I'm going to start at the top here at B. And it says 16 multiplied by 3. Well, I notice that at the top of this prism, I have a layer of 16 unit cubes. And I can see from the height that I could use 3 layers of 16 unit cubes to find the volume of this whole prism. So 16 in one layer multiplied by 3 for the 3 layers does in fact represent an expression that could get the correct volume for this prism. Now another way of determining that is if I further simplify this expression, 4 and 4 is 16 by 3. So there's a couple different ways that you could recognize that 16 by 3 is a matching expression here. Okay, so let's look at C. 16 times 16 times 16 times 16. Well, that seems like that would get me a pretty big product because I know that 10 times 10 is 100, so there's certainly not 100 cubes here. So 16 by 16 alone is going to give me way more cubes than is realistically in this prism. So I'm not even going to investigate that one any further. But let's look at E. E says 12 plus 12 plus 12 plus 12. And this one I'm a little more intrigued about because I see that if I think about this rectangular prism differently, instead of thinking about the prism as having a layer of 16, I could think of this prism as having a layer of 12 as well. So there's a layer of 12. Well, if I look going backwards here, or down the width of the prism, I see there's 1, 2, 3, 4 layers of this 12. So that would correspond to 12 times 4, or if we thought about that as repeated addition, 12 plus 12 plus 12 plus 12. So option E is also an expression that represents this volume. All right, so this is the last question. This by far has generated the most questions among students and parents alike. So, the question states, May's class is designing a garden with 2 levels in this general shape. So what we have here is supposed to represent this garden that May's class is building. And we see there's, here's one level and here's another level. So, we are told that the garden should have at least 200 square feet for the plants. We are also told that the volume of this garden should be less than 500 cubic feet. So we have two tasks associated with this question. Task A, we need to recommend side lengths for the tiered garden that fit the needs of May's class. Now this word tiered simply refers to the fact that there are two levels. Okay, so we need to recommend side lengths. We need to recommend a length, a width, and a height. We need to assign numerical values to these dimensions so that they satisfy these two constraints. So the first constraint being that there has to be at least 200 square feet for the area of this garden, and then the volume of the whole garden should be less than 500 cubic feet. Question B and question A are really the same thing. They want you to pick or come up with 3 different dimensions that will satisfy these criteria, but once you've discovered them and then labeled them, you've really taken care of A and B. So A and B are a lot of wordage for really just labeling this garden's dimensions. All right, so when we're talking about squared feet, we're talking about an area. So when we're talking about an area of something, we're talking about squared units. So if you're buying a new house and you're wanting a house that, let's say, has at least 1,600 square feet, you're talking about the ground floor level of each room, okay? And so if you kind of think about it this way, this bottom layer here, or the base of this figure, needs to have an area that's at least 200 square feet. Now, I'm going to go through kind of some trial and error here and kind of show you what would work and what wouldn't work. So let's say that I decided to make the length 12 feet and I wanted to make the width 10 feet. Well, if I find the area by multiplying length and width, 12 multiplied by 10 gives me 120. Well, 120 is not going to cut it because the area has to be at least 200. So I'm going to have to make some adjustments here. So let's keep the length 12, and let's increase the width here to 15 feet. Okay, maybe that'll work. So let me work that out here. I'm going to find the area here by multiplying 12 and 15. So I only get 180 square feet. So I don't quite meet this criteria, but I'm getting close. So let's make the width 18 feet. All right, and let's try this out. And what I'm doing here is really a simple method in math, just called guess and check. Use what you know about numbers to estimate or to guess, and then check to see if it works. And if it doesn't, go to plan B. If it does, great. So 12 and 18. So 8 and 2 gives us 6. 8 multiplied by 1 plus 1 is 9. 1 and 2 is 2, 1 and 1 is 1, and this is looking promising here. I get 216. Okay, so now I have an area, a base area here of 216 square feet. So that's excellent. That takes care of this first requirement. The second requirement, though, says the volume should be less than 500 feet. Now, the only other dimension now that has an effect on this volume is the height. So whatever the height is, when it's multiplied with 216, it should give us a value of or a value under 500 cubic feet. Okay, so let's say I start with 3 feet. Well, I know volume can be determined by multiplying the area of the base by the height. So I'm going to multiply 216 by 3. Ooh, and I get 648 cubic feet. That is too big. I need to get something less than 500. Okay, so I'm going to try 2 feet. So I'm going to multiply the area 216 square feet by 2 feet. And that gives me something I'm allowed to have, 432 cubic feet. So my height could be 2 feet. Now, of course, some of you have probably thought, well, the height could have just been 1, because I know 1 times 216 is less than 500 cubic feet. And if you notice that right off the bat, that's fine. That's great. But I just kind of wanted to go through sort of the thinking process that might be involved in solving a problem like this. So this is a problem where it seems like there's a lot going on, and in many ways there is. But if we take each constraint one at a time and understand the relationship that each of these dimensions have with each other in terms of finding area and finding volume, this is a manageable problem. But I recommend working on a problem like this methodically. You want to make sure that you're double checking to make sure that you're meeting the meeting the criteria, and making sure that you've answered all parts of the question. So that takes us to the end of the study guide. As I mentioned in my video going over the practice test students took Thursday, I will have a bonus question on the unit test. And I didn't tell the students what that bonus question is going to be over. But if you've watched the video, I will give you a hint. That hint is recognizing that the area of a rectangular prism's base multiplied by its height is another way to find a prism's volume. So I hope you guys find this video helpful. I wish you luck in your studying, and I wish you the best of luck Monday when you're taking the test.